Solve triangle ABC given that. All right, we need a triangle. How come this isn't? Is this in the right notes? Oh, this is period 6. No wonder. I got the wrong one open. So let's get rid of that. Or at least let's get rid of this part so the 6th period children can figure that out. All right, do that. Close that. The blue triangle and the red triangle. Nobody knows which one it is. That's what the ambiguous case is all about. What we have here, if this is an acute angle, then angle B is down here in the blue triangle. But since we do not, why do I have B down? I should not have. That should be a B, shouldn't it?
Yes, it should.
Oh my goodness. Because since the short angle is opposite, or the short side is opposite the angle, what we said yesterday was, you know nothing about angle C. Okay, if you're a Hogan's Heroes fan, then you would find that humorous. Thank you very much, Mr. Schweikert. I appreciate it. We know nothing about angle C. We know nothing about side C. Because those things are unknown to us, stay with me. Just like I was showing you yesterday, I don't know if angle C is like this or angle C is like this. If you think about this, and you would extend this down here, it would be almost like the radius of a circle that is cutting through those 2 points on the base. So I don't know whether it should be here or whether it should be over here. I am not changing anything about the triangle that we already know. This is still 30 degrees. This is still a length of 7. The length of 6, I don't know if it goes this way or if it comes back and goes this way. I just don't know because I know nothing about that angle at the top. So if it's not locked in, how do I know if it's this way or this way? And if that side on the bottom is not fixed, then I'm not sure if it's this long or this long. So there's 2 different possible triangles, and we need to solve them both. It's like we're solving 2 different questions at the same time. It's awesome. Yes. Okay. We can find the sine, we can use the sine of A, right? We do have to use the law of sines, right? So sine A, which is 30, why am I putting A? I don't know. Sine of 30 over its opposite side equals the sine of angle B over its opposite side. I agree with you right now. You can go through the process of solving this, right? Proportions. And what you're going to find is that angle B is acute in this particular, because the sine, what's the range of the sine inverse function? We know this answer. The range of the sine inverse function. It only spits out angles between what? 0 and pi would be cosine inverse. I want sine inverse. Sine inverse spits out what angles? If we thought about it on a circle, we said it was the right half of the circle. Remember over here? What do we call these over on the right half of the circle? Okay, 3 pi over 2 is in the positive direction. We called it negative pi over 2 to pi over 2. That was the range of our inverse sine function. You can't forget this stuff, folks. It's on the final exam. So when you invert the sign in this question, your calculator will give you an acute angle. That doesn't mean that's the only possibility. That does mean that is one of the possibilities. So use your calculator right now and let's find the degree measure. Ooh, let's see here. 7 sine 30. Oh, we should know the sine of 30. Isn't the sine of 30 1/2? Divided by 6. So we got 0.583 for the sine of E. Okay. A little repeat action there. Okay, and then we sine inverse that. So the acute version, so we're going to do two different triangles here. Okay, triangle number 1. Angle B. 35.7. We'll just go 35.7. We'll try to make our life as easy as possible. Now, we'll get to the second one. Suppose angle B is what side opposite A is facing? Okay. In the first triangle looks like this. Ooh, I did not do that well enough. The first triangle looks like this. It's got 30 down here, it's got 7 here and 6 there. The second triangle has 30 down here, 7 there, but 6 coming back like this. I don't know which one it is. I do know that there are two possibilities, because you can't tell me that angle B is acute. There's nothing that tells me that angle B is acute. It is a possibility. This is why this is called the ambiguous case, because you don't know which one of these triangles it is. We don't have any information about the top angle or the bottom edge. If I don't have that information, then this triangle could go either one of two ways. All right, so if angle B is 35.7, what's angle C? Use that handy dandy machine. 180 minus 35.7 minus 30. What'd you get when you subtracted the two known angles, the 35.7 and the 30, away from 180? 114.3 degrees. Okay? It's bad looking. All right? So if that's the case, we have enough information to find side C now. Right? We have sine of 30 degrees over its opposite side equals the sine of 114.3 over its opposite side, C. So, what do we get for C in this case? And let's look at green. C equals 6 sine 114.3 divided by sine 30. What'd you get? Something over 10. How do you participate? Yes. Yeah, that's good. We'll go 10.9. Okay, try to circle that to separate it. You're just cross multiplying, right? So all we're doing is this times this divided by that. Yes.
Did you set it up so you know like A and B is like across from each other?
Okay. All right. Hold on. Let me pause for station identity. Okay, now. What kind of triangle is this green one that I'm about to draw? What kind of triangle is it? It is not equilateral, but it is isosceles. Okay? Three-sided triangle, okay? Get that kid a drop ad for him. Oh, yeah, today's the last day. So the green triangle is isosceles because this side is 6. What did we learn in geometry about the base angles of an isosceles triangle? They are the same. So if this one is, what was it, 35.7? So if that's 35.7, then that means this has to be 35.7. So how in the world are we going to find the obtuse possibility for angle B? Because, okay, now, so good question. How did I know it was isosceles? Side A was given to me as 6. This is side A, opposite of angle A. In this bigger blue triangle, this is side A. But if you flip this around to the red one, this is still length 6. It's not changed. It's still side A. So this green one has to be isosceles. This is the first time I've done this with colors. It's awesome. With chalk. Actually, I did it up there with, and I just wrote on paper, you know, under the camera. So I don't think I used colors, but it's definitely not as cool as this. Okay, so you guys should learn it much better. All right, nice thought there. 180 minus 35.7. So it's really not that hard to find that other angle, that other possibility for angle B, because they form a linear pair. So in triangle number 2, angle B is going to be that 180 minus 35.7, which is what? One 140 what? Isn't it 144 something? 144.3? Okay, nice to meet you. Is that a first or a middle name? Nice. Zachary confused. Okay. So, all right. I'll go back to the picture. The picture speaks 1,000 words, right? That's what they always say. So if we know that this angle right here is 35.7, all we're doing is using what we know about a linear pair, supplementary angles. No, the red one is what we're, I guess I should have used red. Sorry, I should have used red. If I was a cooler teacher, okay, I would have used red for this. Okay. Yeah, people are going to be like, why does that say red there when it's all blue?
You should have done it in blue.
Okay. Remember it. It's all irrational day since we're celebrating pi again. All right, now. Angle C. If we know that angle A is 30 and we know that angle B is 144.3, what the heck's angle C? 6. Yeah, what is it? 5.7 degrees. It's skinny. It is skinnier than I drew it. This is a completely different triangle, folks. It's the reddish looking one up there. Or if you want to see that, the green one down at the bottom. Yes. No. Okay, the blue one. You see the blue one? The big one. Okay, that's triangle. I should have used, you know what? This is going to really mess people up. Yeah, I know. And then I screwed it all up. So this is the blue triangle. And this is the red triangle. The green one is just for kicks and giggles. It helps illustrate what's going on. But the green one is just for illustrative purposes only. Okay? You just need to do more of this in order to get it. Okay, so now, if we know side C or angle C is 5.7, we need to find side C, right? Because we got the 5.7, and we got the 144.3, and the 30. Right, this was 35.7, 114.3, and you guys found 10.9 on the bottom there. So now I've got to do the law of sines again. This is why this is such a cool problem. Sine 30 sine 5.7. Do you think side C is going to be bigger than 10.9 or smaller than 10.9? Thank you. That is awesome. All right. Using the handy dandy machine. 6 sine 5.7 divided by sine 30. I got 1.2. That's awesome. Oops. All right. The same basic pieces of information, the 30 degrees, the side 7 and the side 6 remained the same for both triangles. It's just because we didn't know this information at the top and bottom, this angle and this side, that I could not tell you which one it was. And it all happens because of this. You better understand that when you draw out the triangle, it's critical that you know where you're placing the information, and you can look for this, that short side across from the angle. If the short side of the two sides that you're given is across from the angle, ding, 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 2 solutions. That's that ambiguous case. There's only 2 triangles that it could possibly be. Right. So you would have a larger triangle. That would be triangle number 1. And then inside of that would be the smaller version of it. Basically, you're cutting off that isosceles triangle on the end part. Correct. Correct. That doesn't change. Yes, I know we need to practice that one. Okay, I understand that one. You definitely need to practice this ambiguous case. It's not hard to find the second triangle. It's just that you're, trying to wrap your mind around this whole thing. Okay. Locating a fire. Now, some of you will probably just look for the smoke. But Forest Ranger Chris Johnson, isn't that the name of our assistant principal? Okay. I did not know. I'm gonna let him know that he is famous. I will do that, yes. So Forest Ranger Chris Johnson and Ranger Station A sights a fire in the direction 32 degrees east of north. Now, they show you that in the picture. I don't know if you're aware of what they're saying, so I'll zoom in on it. But north, and they're going 32 degrees east of that. Okay?
How did he spot the fire?
So he obviously Ranger Johnson is right there. Okay? Because he needs to locate where this is at so they can send choppers with the tanks of water, drop it on the fire.
Well, you see, he's not a security guard. He's only a security monitor. He only knows.
Okay, I don't get that one.
There's a problem.
Okay, so
No, that was a credit card.
Ranger Rick Thorpe is obviously he's been demoted because he's not a forest ranger. He's just a regular ranger. Okay, so Ranger Rick Thorpe at Ranger Station B. That's over here. Whoa, gotta lock it in. Is 10 miles due east of A. Why did they say A? Why don't they say Forest Ranger Chris Johnson? Okay. He sights the same fire on a line 48 degrees west of north. Obviously, you can see in the picture how they drew that out. Find the distance from each ranger station to the fire. So they want side A and side B. Okay? So we need to look at what we have here. The fire is at point C. Now, what angle is down here in the lower left? 90 minus 32, which is 58. I know. We always, in our minds, we always think about 100. When we subtract from 100, I don't know why it is, but we always do that. Okay. All right. So what about the angle down here in this corner? 42. What about the angle at the top? It is? Let's see, that's 90, that's 100. Yeah, that's 80. Okay. Do we have enough information for the law of sines? Yes, we have a known angle and a known opposite side. Sine 80. Let's just hope he can type fast on a calculator while the fire burns. And then we got sine 42 over b. And then, of course, you're going to do this again. Sine 80 over 10 equals sine 58. 58 over a. Okay, use your machines and find these things. Now. Okay, so we did a little cross multiplication, right? This times this divided by that. This times this divided by that. And I got a b value of 6.8. And 8.6. Yes, we found all the miles that they wanted me to find. I think we're done. Find the distance from each ranger station to the fire.
Did they do that on purpose? So all I do is flip the numbers around?
No. No. Expressing our feelings on the matter. Okay, we'll put it in a narrative for English class. Say what? I mean, it's not really that bad, but first it's kind of sounds weird. The road slopes 10 degrees above the horizontal. Okay? So we already have a 10-degree slope to the road. Okay, then we've got this telephone pole. Now, when they install telephone poles, do they go straight up or do they go perpendicular to the road surface? They go straight up, folks. All right, so if the road is angled, all right, we don't have poles that are like, like this, because they had a protractor down there and they were like, make sure it's 90 degrees. Okay.
Yeah, but what's the like?
Okay. Okay, so in other words, then somebody stood away from the pole and measured the angle of elevation to be 62 degrees. This is not a right triangle. You have to understand it's not a right triangle. Okay? Angle B, I don't know why I put 80 in there. It should not be an 80. Should it? This shouldn't be 80. It should be 90. So the whole thing is that right? Is that right? Let me back up. Back up and think. Right. So in other words, the pole to the ground is less than 90 degrees. It's 80 degrees because the road's coming down like this and the pole's going straight up. So it has to be less than 90. So that is right. It's an 80-degree angle. Okay? So what does that cause this angle in here? Sorry, you got to actually be able to see what I'm writing. What does that cause this angle in here to be if the pole is making an 80-degree angle with the ground? That makes that 100 degrees. Okay? 100 degrees. Okay? We have Inside here we have 100 degrees. Okay? Now, angle A See, what I don't like about this particular problem is they said the angle of elevation is 62 degrees. Well, if I'm at the bottom and I'm measuring to the top of the pole, now I would think that would be right here. But in the notes, they suggested we subtract 10 from that, but I don't get why we would do that. It's just not. They said the angle of elevation was 62. Now, the angle of elevation of the sun is 62. Now, I think I know what they're getting at, and I think that's a very poor way to say that. Who in their right mind, what are we doing? We're jumping up on top of the telephone pole to measure the angle of elevation? Okay, we're going to be on the ground measuring the angle of elevation. So I see what they're getting at. Based on the way they've defined it, I wouldn't have defined it this way, because we're just going to be down on the ground. They should have just said, from the ground, the angle of elevation is 52. That's what they should have said. Okay. Well, based on where they measured the angle of elevation, they measured it from a perpendicular surface at the top of that pole. Nobody's up there. Okay. We're standing on the ground measuring this stuff. Okay. So to be realistic, they should have just said the angle of elevation from the ground is 52. Find the height of the telephone pole. Okay, and they said that the pole casts a 14.5-foot shadow. Okay, so obviously that's this side of the triangle because shadows are on the ground. I didn't know if you knew that, so I thought I'd share. Okay, ask your question. All right, now, we need to find the height of the pole. We'll call it X. Okay, do we have enough information to use the law of sines? Do we have a known angle and a known opposite side? No? Yes? Yes, no? Do we have a known angle and a known opposite side? Well, the only side I have is this one. Do we know the angle across from it? Oh, we can calculate it. Ha-ha! We know our geometry. 180 minus 100 minus 52. What are we left with? 28. Oh, so we do know 28 degrees. All right, so now we have the sine of 28 degrees over its opposite side, 14.5, equals the sine of 52 over its opposite side. Get your calculators, go.
Billy is not lying. He is sitting.
No cap. All right.
It said Mr. Taylor's not lying.
I have a lot more to.
Okay, so cross multiplying, we got 24.3 for the height of the pole. Hopefully that's not in miles. Okay. We should move on, right? No. I do want to do one thing in the 5-6 notes, so. All right. So this was the additional term in the Pythagorean theorem that you never saw. Can anybody tell me the cosine of 90 degrees? 0. And what does that do to this term on the right? It knocks it out, which is why you never saw it in the Pythagorean theorem. Okay, so the Pythagorean theorem is a special case of the law of cosines. There are going to be two different types of problems to solve with this. One's easy and one's not so bad, but it has a little bit more work involved in it. It's really not that bad, but Some of you have a difficult time solving this question. Walk me through this question before lunch.
3 plus 6.
Okay, so 3 plus 6 is, and what do you do with that number? Do you add it to the negative 2x? You subtract it,
I was hoping to get a 2.
and then what do you do?
Divide by negative 2.
Okay, I want you to remember that you said this because some of you are going to argue with
it's
me
2.
in a minute when we do this. Well, it'll probably be tomorrow, Monday. Just saying.